principal consultant at a consulting company called Arkahna. I've been there for a couple of months now, probably 4 or 5, and they have a focus kind of more on the Microsoft side of cloud native. Previous to that, I worked at WA News, so I spent 5 years building the west.com.au, Perth Now, and 7 News. We started off quite traditional, EC2, connected to on-prem, big old network, relied on on-premises resources and that sort of stuff. Slowly over time, we moved to containers, and then started moving some of our services that need to burst a lot more, like authentication. We'd send out a push notification, and sort of 8,000 people would click on it to load up the article, and we'd suddenly have to authenticate a heap of requests. That sort of stuff. Moved all of that to serverless and got some really good results. The other thing about WA News is we had a really small development team. At most of the time, we only had 2 people in production engineering, and often around 8, 9-ish devs. For 3 news sites, the back-end tooling for the editors and also a tipping platform at the end, that's not a large team for a heap of infrastructure serving millions of requests a day. So reducing our operational overhead was massive. And one of the parts of that was introducing a culture of DevOps in the team. It's a bit of a cliche term, and I think it's a bit overused, but we actually needed our developers to care about production. And that's what DevOps kind of is to me. And so a lot of the things I'm going to be talking about today are the principles that I kind of learned and experimented with. And about 1.5 years ago, I got fed up with a number of feature toggling products out there, in particular one that we used at WA News, and then I decided to build my own. And it became kind of like my playground for experimenting with serverless tech and building something completely serverless. When you go all in on serverless, you open up some really interesting possibilities because you don't have to pay for it when it's running. We'll dive into a little bit about that soon. So I'm building an application called FeatureBoard, and you'll probably sort of go, why another feature toggling product? I'll cover that in a minute. But today is really just a little bit of a taster of all of the different technologies and patterns that go into it. I've only got a short amount of time, and I had to pick kind of what I thought were the most interesting pieces of it, but I can't go very deep. If anyone's got any questions, and it's just like there's a hole in what I've explained, please throw your hand up and I'll address it as we go, and then we can kind of hopefully fill some of those gaps. Okay, so why another feature toggling product? At the time, the websites we built at WA News, they relied heavily on CDNs. So CDNs are a content distribution network. They're basically used to move the request from the user to entering, say, AWS's network far, far closer to the user. That reduces latency and improves load time, but also CDNs can give you caching. And so what we did is we had a small number of servers that served a huge number of requests. We really used the CDN to enable that. Only about 2 to 3% of our website traffic hit our own servers. Everything else was kind of dealt with by the CDN. That was the first problem that I wanted to solve. The existing feature toggling products out there, they work against users. They need to know who the user is to be able to do any sort of A/B testing, and that immediately destroys your caching. Because as a news site, you have lots of users that get one website. So if we suddenly included the user into our cache key, we'd be stuffed. So that was the first thing. I wanted a product that I could do A/B testing with that worked for CDNs. The second one is, and this is just context for the product that I'm going to kind of dive into, because I think it's kind of important. The second one is kind of same configuration in all environments, because syncing configuration across environments is really painful. This was built kind of for news sites that have memberships, so you have a membership level, and that's kind of what I want. There's no point having a different configuration for membership levels in dev and prod. That's the sort of thing that you want across all. And finally, I wanted something that handled authorization, so roles and permissions, because often the features that are released to people who have like access in terms of a plan, like you're in a professional plan, you get access to this feature. There's also, in an organization, you have the roles that also have access to the feature. And it annoys me that you always have like 3 systems to deal with feature toggling. You've got one for like site reliability engineers and production engineers. You have one for kind of your product team to control rollout of the things, and then you have kind of another one to deal with authorization. So I thought that was dumb, and I wanted to combine that. So that's kind of what I'm building. Quick demo of FeatureBoard, just so you've got a visual. There we go. This is FeatureBoard. There's 2 parts to it. I have audiences, which are kind of roles or the plan that you have, and you have feature categories down from the top. You've got permissions. So we'll start with plans. I've got small, medium, large. If I go into, say, the medium plan, I can see these are the features that are configured for there. I've got like a limit on the number of users, of different types, got a maximum number of projects, what type of webhooks are available, that sort of thing. Being a feature toggling system, there are a couple of things that are quite important. So in here, I want to be able to like toggle environmental availability. The other side of a feature toggling product is that's consumed by lots of applications out there. There's all of these SDKs connecting to this service to get the state of the features. So wanted to be able to serve lots and lots of requests, leverage CDNs, and also push out updates in real time. So if you make a change here, it pushes it out to all of your services, and you get that immediate feedback. So that's kind of a bit of context. I'm not going to go deeper into the product itself, but that just gives you context. Any questions before I move on? Kind of like what the product is and how it works. Excellent. So that was a quick bit of background. The rough agenda, and you can see there's a lot of things I'm going to cover. I want to dive into DynamoDB and single table design. It's something that I struggled with quite a lot, and it's kind of the key to unlocking DynamoDB as a technology. You can't approach it the same as you would a relational database. You just won't get the benefit out of that technology. So that was a big learning curve for me. We're going to quickly talk about the HTTP side of serverless, which normally involves API gateway, Lambda, and I'm using Fastify, which is a kind of like Express. It's a Node.js web server. The API gateway, as far as I understand, isn't needed anymore because Lambda supports HTTP binding, but I haven't played with that, so I'm not going to talk about it. You've got SNS and SQS. This is where serverless really shines, is the eventing architecture side of things. And then I quickly want to touch on I'm using Pulumi as infrastructure as code. If any of you have used AWS's CDK that allows you to write your infrastructure in TypeScript, much the same idea. I picked up Pulumi before CDK was released, so that's kind of why I am using Pulumi. And then I just want to talk quickly about mono repo tooling and kind of bringing it all together. So there's a lot of topics. Please chuck up your hands if I skip anything and it's not clear. But each of these things, I found really, really good talks on each of them, but there's not a lot talking about how they all fit together. So that's my goal, give you a little bit of a taste, talk a little bit about how they fit together, and then you can go and look at different talks that give you depth. That's kind of my plan. Let me know how it goes. Serverless, for me, just to set expectations, is 2 things that are important for serverless. It's different for other people. First one is around reduced operations. For me, I am planning on building up FeatureBoard, and I want the operational overhead of it to be quite low. I want to offload that to AWS, so low ops and maintenance. Great. The other one is if it's not being used, I don't want to pay for it. And that opens up some really cool things. So when we built a fully serverless product at WA News, every time we opened a pull request, it would build an entire environment in about 3 minutes. And we had often 10 or 15 pull requests open. In a non-serverless environment, you would just be spending quite a few $100s just on RDS instances to have all of those instances running. It cost next to nothing. So when you get this, I'm not paying for it if I'm not using it, it opens up some really cool possibilities. So that's serverless, or the important aspects of serverless for me. This is, I'm just going to walk through quickly the architecture of FeatureBoard. You'll see there's some repeating patterns. So if we take the console, the APIs, we have CloudFront, which is our CDN. It talks to API Gateway. You're not allowed to talk to the API Gateway directly. You have to go through CloudFront. So you're protected by caching, and you can put a WAF and DDoS protection and all that sort of niceties in front of that. The way I've structured it is I have a single Lambda for my APIs, and I proxy all requests through. I'm going to talk quickly about like the pros and cons of that in a minute. I then stamp out the same pattern for each of my APIs. It's a nice repeatable pattern, but it gives me, I don't have to worry about having servers running. And because each of these are quite small, my cold start time is only about like 80, 90 milliseconds, so it's not too bad. And as you get more traffic, cold start time becomes less of a problem. If you're not familiar with what cold start is because you don't have anything running, you're not paying for infrastructure, it's all turned off. Request comes in, AWS has to load up the infrastructure for your Lambda, load your layer on, start it, now it can issue the request. So having a really big Lambda can slow things down and make that not particularly snappy. So that's something to take into account. The event-driven part of the system is where serverless becomes really interesting. So rather than doing any sort of notifications and talking to external systems, any sort of changes you make through the admin portal are going onto a single SNS topic. We'll dive into this a little bit later, going to multiple queues, and then hitting multiple Lambdas.
I've got a question.
Yeah.
And you don't have to go into much detail because it'll probably
It's all good.
controversial, but did you think about using Aurora serverless instead of DynamoDB?
Yeah, it's a good question. So the question was, did I ever think about using Aurora for like getting serverless RDS over DynamoDB? And yes, but at the time I was kind of really interested in this single table design, which I'll jump into, and it has some pros and cons, but I find the trade-off really, really interesting. And then finally, the last one is separate API gateway. I've got two client connections, one for WebSockets, one for HTTP. So let's quickly jump into Dynamo and single table design to answer your question. The why or why not DynamoDB? For me, databases started off, and Rick Hillehand, who kind of came up with DynamoDB and a lot of the patterns there, he was talking about how back in the day, RDS storage was so expensive, and so that's why a normalized, like third and fourth normalized form was just trying to reduce the amount of data on disk. No duplication of data, because disk and storage was really expensive. And so, but CPU wasn't as constrained. So you could afford to use the CPU to rebuild full sets of data. So RDS tends to be compute bound rather than storage bound. It's optimizing for less storage and uses the CPU to compensate for that. Once again, very high level, but you're limited by one or the other. DynamoDB takes the approach of you can't do computation in it. There's no kind of set operations. You can't do joins. You can't do a whole heap of things. But what you can do is duplicate data and optimize for storage. So we'll just duplicate anything to optimize for reads. And kind of that's where the trade-off is coming in. And so if you can design to optimize for using storage to reduce compute, that's where you get these trade-offs. So it's cheaper to run, it's really, really fast, and it scales horizontally forever.
Sorry, I'm not very familiar with DynamoDB. Is that a document database? Or?
DynamoDB is a document database, yeah. I'll show you the kind of the basics in just a sec. talked a little bit about this. Relational DBs are super flexible. They use the CPU to be able to join across tables, create join and projections and all of that sort of stuff. The downside is they need access to all of the data to be able to do this. There's always trade-offs. If you don't have access to all of the data, you need to effectively be able to split your database into multiple and shard it or partition it, and that you have to design for in RDS. So both of those are kind of your trade-offs. But from a fundamental point of view, RDS, you need access to all of the data in one spot, so it can only vertically scale. DynamoDB splits up the data, so it can split over heaps and heaps of servers, so it's horizontally scalable. Uses storage to do that. The downside of DynamoDB is you need to know what your data is and how you're going to access it before you start working. In RDS, you can just kind of come up with your schema, and then you can just use SQL to work around any deficiencies in that. That doesn't work with DynamoDB. If you stuff up your modeling, you are in a world of pain. So at a very high level, I want to introduce, because we can't join, it would be super inefficient if I wanted to get my environments and my features and my projects and had to go to all of these different tables. I'd be doing heaps and heaps of round trips, and it'd be really, really inefficient. So the solution to that is a pattern called single table design. The way it basically works is you would have some sort of differentiator as an attribute, which would be, say, the row type, and then all of your data has two things. It has a partition key, and that's what DynamoDB uses to shard your data. So ideally, that should be nicely distributed. Pick a customer ID or something that will distribute nicely. And then secondly, you have a sort key, and those are a composite key that identify each row. Right? So I have an organization similar to a GitHub organization. It is a FeatureBoard customer. You then have feature categories. That could be kind of your release toggle or your kill switch or your plan limitation or something like that. They're the different things. You'll notice the sort key has a string, feature key hash, and then the ID. So I'd have a whole heap of these with the prefix. I then have projects. That's project hash, the project ID. I then start building a hierarchy using my sort keys. So a project has an audience, and an audience is a plan or a role, and then I have the audience ID. A project also has an environment ID, and a project also has a bunch of features. So now I've started building a hierarchy. That hierarchy can go down further. An environment has feature availability because I can turn a feature on or off for an environment. So that is another level down. Each of these are different rows. And then I've also got audience exceptions. That this is the targeting override, that an admin can see this. If it's not an admin, it falls through to the default value. So that's kind of what a table in DynamoDB using single table design would roughly look like. Where it gets interesting is querying. So if I do a query and I have partition key equals organization ID and the sort key is organization, I'll get this row. I can also get a project. That's kind of nice. It's kind of basic though. Where it becomes really interesting is I can use a begins with query on my sort key and say, I want all projects from this, with this prefix. So that will begin with project ID, matches all of these, and gives me the project and all of its children in one go. That allows you to take a slice of your data in one operation and get a full, the entire hierarchy. Now this becomes really problematic in an RDS thing because if you're doing this, you're joining across a whole bunch of tables and you get a bunch of duplicated data because of the cross-product issue, or you have to do multiple round trips to the database. So this allows you to optimize your reads. So this is where the trade-offs come in. Now, this is not very flexible, because if I say want to get all of the projects for an organization, I can't say, like, I can't just match on project ID hash and then a partial match. It would give me all projects and all of its descendants. So that's where you need these other ways to query data. But you can do this at any level. So if I want just an environment, I can kind of go further down the hierarchy, right? So where you kind of, we were talking about storage is cheap, you pre-compute aggregations. This is the way you get around it. So this is the event-driven architecture. On the back of DynamoDB, every write operation emits an event. So you've got a stream of events, inserts, updates, deletes. You then subscribe Lambda to that, and you can react to every write operation that's happening in your database. An example of, what I want is, I want to be able to, the little number of how many features are in a particular project, or I want to be able to do that. So I handle the insert event when the row type is feature, and then I want to update the attribute for the project and add one. Now, using this, it's an increment operation rather than fetching the row and then adding one and then putting it back that would have race conditions. This is adding one to whatever the value is, so you kind of get rid of those race conditions. Now, I'm keeping track of how many kind of children of a type are, and I don't need to fetch the project and its features to do a count. I can just grab the project and it has the count on it. So these are the trade-offs. You have to manually keep track of these children, which makes it super, super easy to read and really, really efficient. But you have to do your accounting yourself. You can't just join and do a count subquery and put that as a column. Where it's also really interesting is I can create secondary kind of read models. So I can add a feature list. So whenever I add a feature, I can insert a new item, which is a list, feature, project ID, and feature key. And now, as I'm inserting features, it's creating me a list of items which are just the features. And now I can do a select and not get all of the children. So this is kind of your manual accounting, bit of upfront effort. You have to understand and engineer for better reads. But it's hugely scalable and very, very efficient. So all of your reads are going to be like single-digit milliseconds, and that doesn't matter how much data you have. It'll stay running really well. Any questions on that?
So is it fair to say that your configuration for each board is stored in DynamoDB, or is it stored in other services inside of it?
The question was, is the configuration for FeatureBoard in terms of like the user's feature configuration? Is that what you're saying?
Maybe just the environments as well, because like think DynamoDB is like, what if you have some, this is just my naive, in my ignorance about the FeatureBoard, but you have some like sensitive data, things of that nature.
So if you're talking about like leakage of data, and if you're kind of too permissive in your reads and you're bringing back stuff you're not supposed to.
So I guess I'm wondering about like what you put in DynamoDB. Is it the entire configuration for the entire all the projects in the environment, or do you share that configuration? Like, well, we put most of the stuff in here, but we also use this other service for the whole project.
Yeah. So all of the user data. The question is it all in DynamoDB? So all of the customer data and all of their configuration is in a single table. At the moment, yes. My plan is to separate those into management. So you've got your management side, and then I'm going to use the stream to build a secondary, just the values, and all of the client SDKs will use that. So you can create secondary read models, and then all of my client Lambdas will only have access to that table that doesn't contain a lot of information. And this is what, when I get into the next thing, I'll call something out when I get there. And then I can list all the things with this query. So that is single table design. There's really, really good reInvent talks. There's a lot to it. I just wanted to give you a taste and a little bit of an idea what it is. Next up is the API gateway, specifically HTTP. So when you're dealing with Lambda, there's two kind of ways you can deal with Lambda. Synchronous invocation, which means the Lambda is going to return a value, and then there's asynchronous invocation, which are things like messages, where you normally will send another message or they'll write to a system, but they won't necessarily return anything. All that happens is if you don't throw an error, it will remove all of those messages from the queue. So those are kind of the two modes. Specifically, we're going to talk about HTTP, which is invoke a Lambda, wait for it to give you a response, and then send that response to a person. For that, I use a pattern called fat Lambdas. Now, there is a term called Lambda-lith, and if you just want to get rid of your operations, you essentially just zip up your web app, put it in a Lambda, and off you go. Now, Lambda-liths have the downside of similar downsides to what your traditional application is all of the routes, and it can access all of your cloud resources. One of the big advantages of Lambda is you can finely control your execution policy. So an individual Lambda can only access the AWS resources it needs and no more. So that's why you kind of break it up. The fat Lambdas pattern allows you to group a whole bunch of routes together that have the same amount of access. This is really good because you don't have to operationally support heaps and heaps of Lambdas. So that's kind of and it's really only applicable to HTTP. You wouldn't use this pattern for like asynchronous Lambdas because it doesn't make much sense. What does that look like? I'm using a package called AWS Lambda Fastify, and then I have my Fastify app here. I'm using TypeScript and Node. There are equivalents in other languages, but I don't know a lot about them, so we'll just go with this. So what happens is I import my Fastify application, and I pass it into AWS Lambda Fastify. That returns a Lambda event handler. So what happens is Lambda API gateway triggers the Lambda invocation. It gives you the HTTP event with the verbs and the path and all of that sort of stuff. This function here, or this library here, will map that AWS Lambda object into a Fastify request and send it through the pipeline. It then gets a response, a Fastify response, and it maps it back to a Lambda response. So there's no HTTP listeners or anything. It's not listening. It is just purely object mapping between AWS Lambda shape and the Fastify shape. Sending through the pipeline, map it back, give it back to Lambda. So it's just like a really lightweight mapping. The cool thing about this is for local dev, I just go .listen, and now I've got a local dev server. There are a lot of ways. There's kind of two modes of development. There is, well, three if you include this when you're working in the cloud. There is bring the cloud to you, and that's local emulation. So they've got containers that allow you to emulate a Lambda locally. So you can do that, bring the cloud to you. You can also bring the developers to the cloud, and that's using things like Gitpod and GitHub code spaces, which are remote development environments that are running in the cloud and make it really easy to just quickly use your infrastructure as code in, like Pulumi supports watch mode, so every time you save, it'll push your changes in. AWS SAM has the same thing, it'll sync code changes into your Lambdas live. So you can do that. You can bring the developer to the cloud and make those incremental updates nice and quick. Or this way gives me hot reload, so I can make a change to my server, it'll detect it, it'll restart in like 200 milliseconds and it's running again. Gives me this nice fast loop. I only use this for kind of like the APIs that serve my front end. That's the stuff that I want to iterate on quickly, and then all of the back, like all of the events and that sort of stuff, I'll deploy into AWS and use that natively rather than trying to emulate everything locally. So Fat Lambda, very useful pattern for just stuff you want to iterate on quickly. Got some rules for splitting out Lambdas. I've touched on a few of these. First one is reducing the execution role privileges. There's no point, if you have two databases one containing the kind of crown jewels, all of your admin information, and a whole bunch of PII. You don't want your client SDK to be talking to that database. So you would split those two, so they have different execution roles, and the client Lambdas are only allowed to talk to the client database. So that's one reason you'd split things. And also if you've got routes within the context, like a good example is a file upload, split that out, and because it has the ability to write to S3 and only make that file upload Lambda have write access. All the others have read access. Something like that. That's a good reason to split out. Large dependencies. We'll go to the file upload again. Let's say it's a file image upload, and I have a native dependency that resizes the images. That's going to be massive. I don't want all of my APIs to be paying the cold start time for that native dependency. Split it out. Finally, different settings. So if it needs more memory, also if something's slow and you need to increase it so it times out in 10 seconds, you don't want to be increasing the timeout for all of your APIs that only need to time out for a second. Split that out. So they're kind of the reasons I would create multiple Lambdas, but other than that, I don't have a problem with it being in one. Any questions before I move on?
Like with that means you can debug, you debug all that stuff.
Yep. Yeah, so the local dev, I'm starting a node process, and I have it set up that I can hit F5 and VS Code will start and attach to the process, so I kind of get that best of both worlds. I don't have to worry about like trying to attach to a process running in a container, which is quite challenging. So the next one is SNS, SQS, and Lambda. This is going to be your bread and butter of an event-based system. And there's 3 services there. It wasn't, when I started with AWS, it wasn't immediately clear why I needed to use all 3 of these. So I'll quickly recap what each of them are for. First one is SNS, or the Simple Notification Services. And like most things in AWS, they're quite simply named. It is for notifying things. It is an ephemeral service. If something isn't subscribed when you send the notification, it is gone. It will, if things are subscribed, it will try and do retries and that sort of stuff to kind of be a good citizen, but it really is designed for fan out, and if it loses a message, that's kind of, oh well, doesn't really matter. It's the notifications that are mission critical. If you want those notifications to be kind of not lost, then you move to SQS, which is a simple queuing service, and it is a message queue. So the idea around a queue is it will buffer it and wait for you to connect and get those messages off it. Nice thing about SNS is that actually, if you subscribe Lambda to it, it is pushed. That will immediately invoke. If you're using SQS, there is a slight delay because there's polling and stuff, but you do get the guarantees of at least once delivery, which is really nice. And generally use a queue because you want to do something. Rather than just notify everyone and it is if something happened, it is, hey, do this thing. So point to point. Finally, Lambda, it is event-driven compute. Doesn't matter if it's an HTTP event, someone's calling it, or a message. It is all, I run this function when something happens. So those are kind of the 3. And you'd often use them together. We have SNS with a number of queues subscribed to it, get the fan out, and then you get to control retries and error handling per queue. That's kind of why you do the fan out approach. What that looks like in FeatureBoard is I've got every change that happens in the system around new accounts, plan changes, billing rejections, trial expirations, all of that sort of stuff. And also environmental switches and changing values and all of that. It's all published through this changes topic. And I have, if it's something to do with authorization, I have an auth0 handler that will go update your roles in auth0. I have an autopilot queue, which is my marketing and automation system. So, hey, new customer signed up, it will create them in here so it can start sending them emails. I have webhooks for the marketing site. I thought this was pretty cool. I used Pulumi to talk to FeatureBoard when it did the deployment. And so I had a feature configuration that was auth enabled. And what I could do is when I turned authorization or authentication on, it would deploy my marketing site and it would put a Lambda edge in front of it that forced you to authenticate. So just by going into FeatureBoard, turning authentication off, I made my marketing site live because the webhook called GitHub Actions, which triggered a build, which fetched the latest config and deployed the site using the new config. I thought it was cool. And then finally, I've got the webhook notifier. So if you're using the SDK in live mode, it has a WebSocket connection to FeatureBoard. When you make the change, this eventing infrastructure goes here, looks up to see who for that client has a active connection, and then uses, this is one of the nice things about API Gateway, it has native WebSocket support, and so AWS take care of all of those incoming connections, managing them, and all I have to do is say, send this message to this client, and off it goes. So that's kind of the WebSocket, WebSocket notifier. So the question is like, did I have just one queue and then growing from there? Because FeatureBoard is a relatively simple product, I just had one topic, which is that announcement topic that I funnel everything through. Then I create a queue, and the queues just drop messages they're not interested in. As you get bigger and the volume of messages go up, you can get kind of your enterprise service buses that have like filters on the subscriptions themselves that give you this more scalable messaging and subscription approach. Like SMS and SQS are super basic, and that's one of the reasons I like it, is because there's not a lot of complexity there. It's just, I have a topic, it fans out, I have a queue, it buffers it until my thing reads it. Nice and simple. As you start going to kind of your event bridge and some of the more event hub, like AWS and Azure, everything starts with event. Whatever the AWS event service is, you can kind of go to the more scalable enterprise service bus messaging solutions. You can do a subscription that has a filter. So your Lambda won't be invoked unless that filter matches. So you can do, that's like one option, but there are also, like, you start creating multiple topics, so you group messages together by the topic. So these are messages related to X, and then you have multiple topics. So that's kind of how you'd start separating it. But for the moment, I just have one. Does that make sense?
You just have one.
I just have one. And I probably will separate it into kind of like client-related topics and admin-related topics, just to separate those two. At the moment, I have one.
Okay, so just to paraphrase, you're filtering.
I'm filtering inside the Lambdas. So they receive all messages, and I drop the ones I don't care about in each. So all of these Lambdas will receive all messages, and I just drop the ones on the floor that I don't care about. Cool.
Just wanted, you could have had that filter pattern in the topic itself. You also align your filter pattern.
Okay, so the comment was you can do filter subscription filters with SNS and SQS. Great. So you can use this and put a filter in the subscription. Thank you. Today I learned. There's too much to learn. Quickly, infrastructure as code using Pulumi. I originally, going back to kind of the way I picked Pulumi, is we were a heavy Terraform shop, but the problem is we had a repo that had all of our infrastructure in it, and our ops team owned that, and the developers didn't go near it. I wanted to kind of introduce a culture of DevOps, and so our team was a TypeScript, a Node shop. Everything was written in TypeScript and Node, And so I picked Pulumi because it would allow us to write our infrastructure in TypeScript. Interestingly enough, this was a pattern that we used earlier to get all of our developers interested in CSS because no one would touch CSS. And so we used CSS and JS to make all of our developers interested in CSS. They were still writing CSS, but they cared more because it was in JavaScript. So we applied the same philosophy to our infrastructure, and it worked. So I'll quickly demo why I like Pulumi and some of the cool stuff we can do with it. Okay, this is FeatureBoard. I am using a really cool extension. Always away. Okay, using a really cool extension called Code Tour in VS Code, it allows you to create a code tour. Really good for onboarding of like someone opens up your code base and it's like, hey, just do the infrastructure as code tour, and then they can self-navigate it. So it allows you to easily create your resources. So I can use TypeScript and create. Can everyone see it back? No. Let's go theme and make it white. Is that a bit better? Good. Okay, so I can create a S3 bucket quite easily. Say it's a website bucket, it's index document, it's index.html. You'd expect that from your infrastructure as code. But you can also allow, as you'd expect, things to depend on other resources. It's a directed graph kind of based language. So it's kind of weird because you're writing a program which is imperative. It executes, but the output of that, every time I go new bucket, that registers that resource to be created. So after the program exits, it knows every resource that should be created. So then it becomes declarative and it does a diff to what the current state is. So it's kind of like your program can be imperative, but the output of it is declarative. Weird execution model, you get used to it. So because it's declarative, I can say this depends on this, and it figures out the order and makes sure things happen in order. You don't have to worry about that. You can also create your own resources. So I've got this throw into S3 custom resource. If we dig into that, it's using something called a component resource. Because we're in a programming language, we can use the normal programming language abstractions. I can create a class to encapsulate other stuff. That's nifty. So what I've done is I've encapsulated a dynamic resource. Now, so there's two types. There's component resources. I'll go back to that in a sec. And then there's dynamic resources. Dynamic resources are really, really handy because I can wrap an existing API. So I want to use the AWS SDK to put a file in S3. That's not a declarative thing. That is I'm calling the SDK to tell it to do something. Right? So I'm creating a dynamic resource called throw into S3, and then I'm creating a resource provider. What a resource provider is it allows me to define a couple of functions in my Pulumi program. So this is like not a separate model. This is just in the code of my Pulumi program. I define create, I define update, and then I implement a diff function. And that gets given the current state and the new state, and then you can do a diff between those to tell Pulumi if that resource has changed. So I just say it's always changed, and that way my update function will be called every time. I'm kind of abusing the model, but I just want to upload all my files every time Pulumi runs. So that allows you to, the possibilities are really cool. Let's say you want to manage your labels on GitHub repositories. You can now wrap OctaKit to create, update, and delete your GitHub labels based on your infrastructure as code config. So I add another label to my config. Pulumi's tracking what exists in GitHub. It will call create or update or delete, and you kind of turning an imperative kind of API into something that's managed in your declarative infrastructure as code. Pretty nifty. And then you can see here, I'm actually just doing an S3 object, wrapping the S3 API. You can put your state into S3, or they have a managed service. Your Pulumi project, you can have multiple, so I've got this one here is my shared infrastructure. So it's got my DynamoDB and any kind of shared services. Pulumi has stacks, so each environment is a stack. So I have a config file for staging, config file for production, and one of the really nice things I like is this secrets provided here is KMS. This is the key, and so I need this key and access to KMS to encrypt and decrypt secrets in this config file. Now the nice thing about that is I can actually just say set a secure value, and it will be encrypted in this file using KMS and that key. And now I can check that into source control securely. If I don't have access to that KMS, then I can't decrypt the secrets in this config file.
You're saying that when you check it, it's going to be encrypted?
It's encrypted, and it can only be decrypted if the person can talk to KMS to get KMS to decrypt that secret. And so it is safe for me to check those secrets into source control, because only people in my team that have access to called decrypt on KMS can actually decrypt. So yeah, so that's part of their config system. And it also uses the same functionality to encrypt things in state as well, which is really handy because you have the state files sitting in S3, and the reason why you go to something like Terraform Cloud is because all of your secrets end up in plain text in the state file. This encrypts those using this, so it's kind of handy. I'm pretty sure that's right. Let me double check. And then because it's a programming language, we already have constructs to export things. So we export a variable, and that will become an output for that stack. So that will, when I go up, it will show me my KMS ARN and all the ARNs for all of the different services that it's created. You can then reference, this is now in my API infrastructure rather than shared, you can reference other stacks. So I've referenced my shared config, and from there, I can require my changes topic, ARN, because that topic was created in my shared. And so now I don't have to set config with the ARN in the following stacks. I can just up one stack, tell it which shared stack, and then it will read the outputs from that other stack. Really, really nice. Once again, component resources, you can create your own logical resources. So I've got a management API, that's my management API. All of the resources that are required to do that are in that class. And you can, it makes refactoring really nice. I can just go, these 5 resources are a logical thing, pull them out into their own class, and then Pulumi will just transparently manage that. If you want, you can also set them the parent class, and then it will create a hierarchy and it will actually appear grouped in the output. So pretty nice way of being able to refactor your resources. I've also got higher level abstractions. So this is a Lambda function. This Lambda function resource I created creates an execution role, allows the API gateway to be able to assume that execution role, and kind of just a couple of things that I want to happen out of the box because I know what I'm building. So I can put a whole bunch of sensible defaults in and create my own Lambda function resource that has all of that in it. And then you can kind of start, because you're a programming language, you can start building some really cool APIs. So here I'm creating a new CloudWatch metric, and this is a higher level metric. So I just need to say this is when executions are aborted. So this is if my step function basically fails, and then it has how many times it's failed. Then I can just go create alarm, and I can add a threshold and evaluation period and kind of the things that I'd want on an alarm, and now I have a metric and an alarm in not much code. And so you can like use programming constructs to create nice abstractions to kind of refactor your infrastructure into nice things. So you get nice things. And this one I think is really cool. And I know the CDK has a similar kind of abstraction for CloudWatch dashboards. But being able to create a new dashboard, have a row widget, live graph metric widget, and then being able to specify, like reference the metric that I created earlier. So really declaratively and nicely being able to build this nice CloudWatch dashboard that has all of my metrics and monitoring in one dashboard, all in my infrastructure. So I create a new environment and it has alarms, it has CloudWatch dashboards, it has everything you need, all deployed automatically. It's pretty cool. And that's Code Tour. While I'm here, I want to quickly talk about NX. So NX is a monorepo tool, and in VS Code, what it looks like is it essentially gives you a project structure. So if you've come from a .NET land and used a Visual Studio and solutions and kind of this IDE stuff, monorepo tooling is the same but works for all languages. So NX is pluggable. It is all written in JavaScript, but it does let you they have plugins for .NET and Rust and Go and TypeScript and React and all of these different frameworks. You can just kind of code gen. So if I go generate, you've got all of these different plugins. So I can create like libraries. I can also create a Node project or a Pulumi project. So it kind of gives you the file new project experience. These are all, there's a massive community out there. But what's really interesting is it knows all of your projects so this is a graph of all of the projects in FeatureBoard. And so it knows all of the dependencies between each and can list, it kind of knows what depends on each. But where that becomes really cool is if I go pm test, and this will run all of the tests. It finished in about a second because it knows there's no files changed in any repo, so it won't rerun the tests. So where I've gone with infrastructure as code is it knows the dependencies. I can say run the up target, which is do a deploy, same as like Pulumi up or Terraform apply, on all of the projects that have been affected. So I merge a change to master, it looks at the commits, and then it will only run Pulumi on the ones that have had code changes using git commits. So like gives you these really, really cool abstractions and a great way of improving your build time and your deployment speed and that sort of stuff.
Does it analyze your code and come up with that?
Yeah, so it has some, the question was, does it analyze your code? It knows about, because it's NPM based, it has some conventions based in, and so it will automatically exclude node modules, but it will hash all of the files in each of those folders to decide if there's changes or not, and you can tweak how it does that. And you can also specify implicit dependencies between each. So that was bringing it all together with NX. That has been a very, very quick run through of some of the more interesting aspects, I think, of FeatureBoard and its serverless architecture. I know I went really, really quick, so apologies for that. I'll be around for a little bit, but hopefully that kind of helped drop a couple of things in place and added some extra context. So thank you.